In this video, we're going to take a look at entropy and try to understand how entropy can let us know if a reaction is going to be spontaneous or not. And we specifically are interested in the entropy formula. So entropy's symbol is S. So entropy is S. We've seen enthalpy, which is delta H. That's a change in enthalpy. Now we're going to have the change in enthalpy. And we'll eventually talk about Gibbs free energy, which is capital G. But right now we're concerned about the enthalpy. And the second law of thermodynamics suggests or tells us that a process occurs spontaneously if the entropy of the universe increases. So spontaneous processes increase the entropy of the universe. So if the universe's entropy is greater than 0, then it's going to be a spontaneous change. And we're interested specifically in chemical changes. So to talk about the universe increasing entropy, we need to talk about the system. So we've got the entropy of the reaction, and if we add that to the entropy of the surroundings, as long as those things are greater than 0, then it's going to be a spontaneous change. And so specifically, the reaction would be spontaneous because both the sum of the reaction's entropy and the surroundings entropy increase. Well, the reaction entropy is what we're kind of most curious about, but the surrounding entropy can be related to the enthalpy of the surroundings, and this is related to the absolute temperature of the surroundings. So those surroundings basically have some energy that's available to them. And so if the sum of the enthalpy of the reaction and the change in enthalpy of the surroundings divided by the temperature is greater than 0, then it's still spontaneous. So these things are all essentially trying to say the same thing. But we have this concept's a little bit tricky. So keep in mind that the enthalpy of a reaction is related to the enthalpy change of the surroundings. So when we were studying it, we said, oh, the change in enthalpy is equal to the change in the reaction enthalpy, right? So the energy change is equal to reaction enthalpy. So what we've got is the change in enthalpy of the surroundings is going to be equal to the negative change in enthalpy of the reaction, right? Because if the reaction is exothermic, it's going to increase the energy of the calorimeter or the surroundings. And so the negative enthalpy of the reaction is the same amount of change as the surroundings. So we can put that concept here, and instead of worrying about just the enthalpy of the reaction or the surroundings, we can make this all about the reaction. So the change in enthalpy of the reaction plus the negative change in enthalpy of the reaction. Now, instead of it being the surroundings, it's the reaction divided by T. If that's greater than 0, the reaction is spontaneous. If I want to simplify and get T out of the denominator, I'm going to multiply everything by T, right? So I'm going to multiply this by T, as well as 0 by T, so that T, the enthalpy change of the reaction, minus the enthalpy of the reaction. And now it's still going to be 0, but now because, so it's greater than 0. So this is still a true statement, right? We've just multiplied everything by T, but it gets the T out of the denominator and simplifies some things. So if I take the temperature, absolute temperature, times the enthalpy of the reaction the entropy of the reaction minus the enthalpy of the reaction, if that's greater than 0, it's still spontaneous. But what we can do is we can reorder this, and what we get is the enthalpy of the reaction minus the temperature and the enthalpy or entropy of the reaction. So what I did is I multiplied both these terms by a negative. I'm going to multiply this by a negative, which has no effect, but now it's going to be less than. So if the enthalpy of the reaction minus the absolute temperature times the enthalpy of the reaction is less than 0, this is spontaneous. And this is the formula that we're going to use all the time. So this is going to kind of a breakdown of how we get to that formula based on our theory that the universe's entropy should be increasing if the reaction is spontaneous. From there, so we can use this formula directly. We will soon be interested in how Gibbs free energy ties into this. But you can see that if you have a negative enthalpy and you have a positive entropy, the reaction will be spontaneous because that number will be less than 0.